You've seen them, right? Those absolutely wild viral videos of a massive military aircraft just getting tossed around in a storm, looking like it's seconds from being ripped to pieces. But here's the thing, it almost never is. So how is that even possible? Well, let's unpack the incredible engineering that makes these planes absolute survivors. Yeah, this is the question on everyone's mind when we see that footage. How can something that weighs hundreds of tons endure forces that seem to just defy physics? It feels totally impossible. But the answer, it's not magic. It's a brilliant, brilliant combination of design, technology, and pure skill. And this quote right here, it is the key to understanding everything. It completely reframes the entire problem. What you and I see as just terrifying random chaos is, to an engineer, a set of predictable physical forces. And once you can predict the forces, you can start to engineer a solution.
So to really get the solution, we first have to wrap our heads around the problem. What exactly is this aircraft fighting against when it flies into one of these monster storms?
Okay, so put simply, turbulence is basically a battle raging in the sky. You've got these massive pockets of air moving at different speeds in different directions, and they're just crashing into each other. For a plane, flying through this isn't like driving on a bumpy road. No, it's more like a boat being slammed by unpredictable waves from every single direction at once. And the power we're talking about here is just staggering. A severe thunderstorm can create updrafts and downdrafts moving at 8,000 feet per minute. That is like an invisible elevator, or maybe a trapdoor, suddenly appearing in the sky, either shoving the plane up or yanking it down with unbelievable force. So, how on earth do you build a machine to survive that? Well, the answer is completely counterintuitive. You don't build it to be perfectly stiff and rigid. Nope. You build it to be flexible. This whole idea just flips our common sense on its head, right? I mean, think about a dry twig versus a green one. The dry, rigid twig, it snaps. But the flexible green one, it bends and it springs right back. Modern aircraft are engineered like that green twig, allowing the entire structure to absorb and dissipate the storm's energy instead of just breaking apart. And the scale of this flexibility is honestly breathtaking. Get this, the wing of a C-17 Globemaster can flex upwards by over 10 feet. So when you see that wing flapping like crazy in a video, it's not about to break off. It's doing exactly what it was designed to do. This analogy is just perfect. The wings are literally converting the violent kinetic energy of the storm into harmless, elastic energy within their own structure. They're absorbing every single punch the storm is throwing, protecting the core of the aircraft from what would otherwise be a catastrophic failure.
Okay, but passive flexibility isn't quite enough. Modern aircraft also have a brain, a kind of nervous system that reacts way faster than any human possibly could to keep the plane stable. This system is built right on top of that flexible physical design.
This is the fly-by-wire system, and it is working constantly, every millisecond. Turbulence can suddenly change the angle of attack. That's just the angle the wing is cutting through the air. If that angle gets wrong, you can suddenly lose lift. But before the pilot even feels a shudder, sensors detect it, computers analyze it, and they make hundreds of tiny adjustments per second to all the control surfaces, keeping that plane stable and flying. It's incredible. Of course, the pilots are absolutely crucial here. While the computers are handling all those tiny micro-corrections, the pilots are managing the big picture. When a huge crosswind hits, the pilot is using the rudder and the ailerons, those flaps on the wingtips, to keep the plane flying straight. When heavy rain starts creating drag, they bump up the engine thrust to keep their speed. It's a true partnership between human and machine. So, flying through a storm is one thing, but military operations often demand doing incredibly complex tasks inside that storm, and that's where the dangers really start to multiply. One of the biggest challenges, aerial refueling. A large tanker plane generates something called a wake vortex, and you can basically think of these as two invisible horizontal tornadoes spinning off its wingtips. Now in calm air, they're predictable, but in a storm, they become just chaotic and violent. So the pilot trying to get fuel has to fly in this incredibly narrow, safe corridor. If they go too high, the tanker's vortex can literally flip them over. If they go too low, they can lose all their lift in an instant. Now, just imagine trying to do that while both massive planes are being thrown around by a storm. It is one of the most demanding things you can do in aviation, period. Another terrifying danger is the microburst. The best way to picture it is like a giant water balloon filled with air being dropped from the sky. As the plane flies into it, it first hits a headwind that actually increases its lift. But that's a trap because it's immediately followed by a powerful downdraft and a tailwind, which causes lift to just collapse. This is incredibly, incredibly dangerous, especially when you're close to the ground. And in arid regions, there's also the risk of a brownout. The downdraft from the plane's own engines can kick up a massive cloud of sand or dust, completely blinding the pilot. It can even foul up critical flight sensors, forcing them to rely entirely on their instruments in those last critical moments before landing. So, with all this very real danger, why is it that those viral videos often look even worse than reality? Well, it turns out your phone's camera is actually playing tricks on you. There are really two reasons for this. First, your phone's camera lens tends to compress perspective, which makes any drops look way more dramatic than they actually are. And second, there's an effect called rolling shutter that distorts rapid movement. That's what makes that incredible wing flex look like a violent, jelly-like wobble. So what you're seeing isn't entirely real. It's an exaggeration created by the camera itself. So when you put it all together, the design, the tech, the pilots, the physics, you start to see that it's not one single magic bullet that allows these aircraft to survive. It's an entire system. Survival comes from every single component working together. You've got deep internal spars, they're like the bones of the wing, providing raw strength. You've got massive control surfaces and powerful hydraulics, giving it the authority to fight back against the wind. The advanced computers provide that lightning-fast response, and specialized engines keep pumping out thrust through it all. And right at the center of this whole system are the highly trained pilots who know exactly how to manage it. And that's really the ultimate takeaway, isn't it? It's not just a strong plane. It's a smart plane being flown by an expert pilot. It is the seamless integration of brawn, brains, and bravery that turns what looks like pure chaos into a manageable and ultimately survivable feat of engineering. And that really leaves us with a final thought. Today's engineering is a brilliant reaction to the known challenges of our atmosphere. But as technology keeps advancing, you have to wonder, what new challenges are they preparing for next? What will the storm-proof aircraft of the future even look like? Thanks for joining us.